Chapter 10 has only 10.1 and 10.2, and we're talking about law of sines and law of cosines. Now, in a right triangle, let's say this is A, this is B, and this is C. We know clearly the Pythagorean theorem, which is A squared plus B squared equals C squared. Right? That's all we know. However, there are triangles that are not right triangles. So let's say this is a triangle A, B, C. The notation is very important here, which means the opposite side of an angle has to be denoted by the lowercase letter of that opposite angle. So angle A, opposite little a. Angle B, opposite little b. Angle C, opposite little c. And it can be shown that law of sines in any triangle, this is in any triangle, not a right triangle. It's applicable in a right triangle as well. Okay? But it's a right, in any triangle, we have sine of angle A divided by A equals sine of angle B divided by B equals sine of angle C divided by C. And this, of course, this is what we call law of sines. And it's valid in any triangle. I would like to see what we do with this and why is this so important. So I like to choose an example. Okay. Okay, so we can start by solving the triangle. So first of all, what does solving a triangle mean? When we're asked to solve a triangle, what does that mean? It means find three angles and find three sides. So solving a triangle requires us to determine all angles and all sides, to measure all sides and all angles. Okay, for the following exercises, use the law of sines to solve, if possible, the missing side or angle for each triangle or triangles in the ambiguous case. We haven't discussed that. In a minute, we'll discuss that. Round each answer to the nearest tenth. So, next one, the top one from the top. For the following exercise, assume alpha is positive, opposite side A, beta is so and so. So they're giving us some information. They are denoting them by alpha, beta, but there is no need. So they could have just used A, B, and C for the angles. There is no need for that. Okay, so because they have to tell us that gamma is opposite side C. So let's start with problem 16 and then we'll go to the next level. Okay? Is that okay with everyone? Okay. So 16 on page 770. Here it is. We're given B, which is 3.5. We're given C, which is 5.3, lowercase b, lowercase c. And we're given gamma, which is opposite side C, so this is angle C. Once we're given this information, I'm not going to use for law of sines and law of cosines. I'm not going to use the alpha, gamma. No, this is for the main part of trig, not for this. There is no need for this. Because then I have to explain what is gamma, what does it represent. There is no need. The notation is very clear. So here's what we have. We have A, B, and C. The opposite of B. The opposite of A is unknown, so it's lowercase a. The opposite of B is 3.5. The opposite of C is 5.3. And angle C is 80 degrees. Okay, so writing law of sines, will be sine angle A divided by A equals sine angle B divided by 3.5 equals sine 80 degrees divided by 5.3. Do we agree with this? And remember, they have to be in that particular order. So let's see what we have and let's see what we don't have. Okay, so from this particular proportion, obviously, I have 1, 2, 3 knowns, and I have one unknown. From cross multiplying, I have 5.3 times sine B equals 3.5 times sine 80 degrees, which means that sine B equals 3.5 times sine 80 degrees divided by 5.3. Do we agree with this? Okay, let's go to calculate. So let's punch it in, a graphing calculator. So we have 3.5 parentheses for the top, although you don't really need it, you know me already. Sine 80, make sure that the calculator is in degree mode. No, it's not in degree mode. Now it is. And then we divide by 5.3. It didn't divide for some reason. I see. It jumped for whatever reason. It did that. Okay. So one more time, 5.3. Why did it? Okay, never mind. 3.5. It gave me a warning when I switched to. Okay, I have. Good. 3.5 sine 80. Yes, I do. And we divide by 5.3. First of all, let's analyze this number. What is the maximum possible value of sine B? For any B, for any angle. What is the maximum possible value for sine? So what can I obtain here? Oh, you can see that. Sorry. Okay, so what is the maximum possible value for sine? How high can sine be? 1. How low can sine be? Negative. Is this a number between -1 and 1?
Yes.
That's awesome. Because what if I get the answer? I'm making the point. What if I get the answer for sine B as 1.2? What would you say? No, you will say the triangle does not exist.
Wait, why can only be between 1 and -1 and 1?
Say it again.
Why can sine only be between -1?
Perfect question. Can anyone answer that? Why sine must be between -1 and 1, and it cannot be above 1, it cannot be below -1. Brian?
I thought the answer was 2 pi.
That's
Then
we're not talking about angles, we're talking about the value of a trigonometric function. We're not talking about angles, right?
90-degree angles.
Oh, shoot. Take the north and
Those are
south.
90.
Yeah, okay. I'm fine.
Good. So we have that sine B is 0.65034. We're asked where we have to determine angle B. Let's do that. How do I determine angle B? What should I do to this number to determine angle B? Of course. Is that clear?
Yeah.
Oh, let me write it because I think it's not clear to everyone. Okay. So we have sine B equals 0.065. If we apply the inverse function to both sides, what happens on the left? What do we have on the left? Just angle B. Because sine inverse will eliminate sine. They are inverses of each other. Do we agree with this? Okay, so that's how we get B. Now we have to apply sine inverse to this. Do not delete what you have in the calculator, because I'm going to do this. second, and sine inverse. And of course, I'm going to recall the previous answer. I want to get the best approximation I can. If I only use 0. or 0.65034, I'm not going to get the best approximation. You're going to say, is that such a big difference? No, it's not. But still, I'll try to be as accurate as possible. So it appears that in degrees, because we have the degree mode, angle B is 40.567. I don't know how many decimal digits to use, because it will make a huge difference in determining the length of a side. It really would. So if you round it up and say 41, you'll have a lot of error. So V equals, let's say, 40.568 degrees. Okay. Let's take a look a little bit before we continue. We haven't determined sides yet, the third side. We haven't determined the other angle yet, but I need a discussion right here, right now. So let's take a look at the unit circle, where we will picture the angle roughly 40 degrees, or 41 if you want. So this is 45, 40, I'm going to say it's here. This is the angle B. I'm going to call it B1. With the same, absolute same height. Because sine, what is this piece? Can anyone give us this measure? This height. How much is this height? Careful. 0.65034. 0.65034. There is another possibility right here. There is a second chance. I don't know if it works, but there is a second possibility for angle B2. What will angle B2 be? If this one is 41 degrees, what could this be? 180 minus 41, right? So that is the same, the sine is the same. So the sine of B2 is this, which is the same thing with the sine of B1, which is this, because I drew a parallel to the x-axis. So there are two possibilities for sine, for B. B1, which is this angle, or B2, which is this angle. I don't know if B2 fits in the triangle. I don't even know, and I don't care for now. But this is the correct analysis. So I could have this option, or I could have this option. Therefore, we'll see in a moment if that's possible or not. So option number 1 and option number 2. In option number 1, as well as in option number 2, A is unknown, so there are two options. B is unknown, so B1 equals 40.568. B2 will be determined as 180 minus 40.568 in a minute, degrees, of course. C is the same. There is no change in C. This is given to us from the get-go. Lowercase a will have two different options. Lowercase b is carved in stone in both. We cannot change that. And lowercase c is carved in stone, 5.3 and 5.3. And I'll tell you in a minute why this happens and what situation this is. Okay, so once I determine B1, I can easily determine B2. How much is 180 minus 40 point? 139 point.
I'm guessing.
Now we can determine A1 and we can determine A2. How do we determine A1? So we have from 180 degrees, we will subtract 80, we will subtract 40.568, and we will get A1. Can anyone give me A1 and I'll calculate A2? So from 180, I subtract 80 and I subtract So what did we get? Say it again.
39.432.
59.39.432.
432.
Very good. And what about, I'm sorry?
I got 59 with the right grade.
So what is it?
59.
Okay, no problem. Perfect. So 59.432, 40 and 80. So here's what I got for A2. For A2, when I subtract 180, when I subtract 139 from 180 and I subtract 80, I get a negative angle, which tells me that the second option is not possible in this case. It's not possible because A2 would be a negative angle. So this option is out. So then we have to continue. We go back to Law of Cosines. We do have everything we need to determine A. So now we will look at this proportion or this proportion. It doesn't matter, whichever you prefer. Let's do this proportion. So sine A divided by A equals sine 80 degrees divided by 5.3. So our next step is to determine lowercase a, because we have a, uppercase A is 59.432. So then sine of 59.432 degrees divided by lowercase a, side A, over 5.3. After we cross multiply, we will easily determine lowercase a. So let's cross multiply and see what we get. And with that, we completed solving the triangle. We determined everything about it. So A equals 5.3 times sine 59.432 divided by sine 80 degrees. So with the calculator, I'll put it in, 5.3. I like parentheses, you know that. 5.3 times sine 59.432. Close the parenthesis for the numerator, and divide by sine 80 degrees. Oops. I got 4.63. So A is approximately 4.634 if you want. So now we can present the triangle. We have everything, we know everything about it. So you can put them in, or you can just list them. So we have angle A, angle B, angle C, 59.432. We have 40.568. We have 80. We have lowercase a, which is 4.634. We have lowercase b, which was given to us from the get-go, and 5.3 for C. Okay. If we go back and analyze the case, you will see what we are given. Side, angle. This is what is given to us initially. Side, angle. This is what we call the ambiguous case. And this is the only one. So the side angle can have, in shorts, SSL, can have three possibilities. One possible triangle that we just determined. Second option, two possible triangles. And the third option, none. Impossible. With the given information, we cannot create a triangle. So here, let's choose one, because it says in the ambiguous case. So in this situation, like the previous one, the side angle, we can expect one possible triangle, two possible triangles, both work perfectly, or there is no triangle. No matter what we do, we can determine, we can form a triangle with a given information. So 24, 25, 26. 26. Okay, 25? 25 it is. I just didn't want you to think too hard. So here's 25. Find angle A when lowercase a is 13, lowercase b is 6, and uppercase b is 20. Please create the triangle and put the correct information in the triangle, A, B, C. The opposite of A is 13. The opposite of B is 6. And angle B is 20 degrees. Is this the ambiguous case? Well, if it's side-side angle, what I'm talking about is what is given to us. So what is given to us is indeed side-side angle. In that order, side-side angle. So yes, it is the ambiguous case. We don't know what to expect, or we do know what to expect, one of the three options. So we will start with law of sines, in which we write sine A divided by lowercase a, which is 13, and then sine B, which is 20 degrees, divided by 6, and then sine C divided by lowercase c. So from here, we have no information in sine C over C, so I don't even care about it, because this gives us enough for determining sine A and then eventually A. We will cross multiply in this proportion and find sine A. Any questions, please stop me. Sine A equals 13 sine 20 divided by 6. What type of number do we expect here? Guaranteed. Between? Right. Well, of course, it's going to be in the first quadrant, so yes. But I expect a number definitely less than 1, between 0 and 1, correct? If I get a number that is, no, it's not going to be negative, but if I get a number that is beyond 1, I'll say that the triangle does not exist, so I can't determine any angle. Okay, so I just plugged it in, 13 sine 20 and divide by 6. Okay, it's 0.7. So it's an angle kind of close to 90 degrees, right? Because at 90 degrees is 1. So here is 0, so somewhat closer to 90 degrees. That's what we expect, right? So then we apply sine inverse to the previous answer. So we don't truncate anything and less approximation. So we get approximately 47.82 degrees. So A is 47.82 degrees. However, remember there is another option of 180 minus the previous answer. So 180 minus the previous answer gives us an A2, which is 132.18 degrees. We don't know whether we are going to end up with two triangles or not, but we have to give it a shot. So option number 1 and option number 2 will look like this. A1 and A2. A1 is 47.82 degrees and A2 is 132.18 degrees. Then we have B, but B is fixed. No one can change B. This is given to us. C will be C1 and will be C2 because we have now two options. From 180, I subtract 47, I subtract 20 to determine C1. From 180, I subtract 132, I subtract 20 to get C2. So can you determine C1 and I'll determine C2. 180. I got 27.82. What do we have for C1? I got 112.18 degrees. So now we continue with A, which is 13, and A, which is 13, B, which is 6, and B, which is 6, and lowercase c1 and lowercase c2. We went beyond what the question was asking us. The question was only asking us to determine A. But I like to make sure that everything is in order and you can always go back and check. And how do I determine C1? So I will determine C1 using this proportion in which I plug in uppercase C1. And then I use the same proportion with uppercase C2. So I write sine 20 degrees equals sine 112.18 divided over 6 here and over lowercase c1 here. Please don't do what I just did. I didn't mean it. Okay, so from here we have C1, which is 6 times sine 112 degrees divided by sine 20. And the same thing on this side, but C2 will be from sine 20 degrees over 6 equals sine 27.82 divided by C2. So this will be 6 times sine 27.82 divided by sine 20. And now we know for sure that the given information enables us to determine two totally different triangles. I shouldn't say totally, they still have some common elements, but they are different triangles. Okay, so I'm determining C1. So 6 times sine 112.18 and divide by sine 20. Correct my numbers if you please do that, if there is anything wrong. And the second one was 27, everything the same, but 27.82. So here's what I got for C1, 16.24, and for C2, the side C2, 8.19. Can anyone confirm my numbers? Yes? Excellent. So now the question is, where do we apply all this? Real world applications. Let's take a look at the communication tower. Here it is. Let's read the problem. Try to understand what is given and make decisions. Okay, a communications tower is located at the top of a steep hill, right here. This is the communication tower. As shown in the figure, the angle of inclination of the hill is 67 degrees. So this line and the horizontal have 67 degrees between the two of them. Okay. A guy wire, which is this, is to be attached to the top of the tower and to the ground, 165 meters downhill from the base of the tower. So this distance is 165 meters. The angle formed by the guy wire and the hill is 16. So this angle here is 16. Okay? Find the length of the cable required for the guy wire to the nearest hole here. So we want to determine this length. We have 165, we have 16, we have 67 between the guy wire, correct? The angle of inclination of the hill. Now that's just the hill. Okay? And we want to determine this length. Any questions? Okay, we have to copy the figure. So let's do that. Because we want to see why we even think of law of sines. So here's why. This is one application. Okay, ready? So this is the hill. Here's the tower. Thank you. Sorry about that. Better? Perfect. Thank you. So we have, it's attached here. This is the x that we don't have. We know that the angle of inclination is 67. We know that this angle is 16. We know that this measure from here till here is 165. We're going to read the problem one more time just to make sure that we put everything correctly. And that's 67, and that 67 is also here. It doesn't matter. That's for the entire hill with the horizontal. Okay. So a communications tower is located at the top of a steep hill. Okay, here it is. As shown in the figure, the angle of inclination of the hill is 67 degrees. This or this, they're all the same, 67. A guy wire is to be attached to the top, to the ground, exactly 165 meters downhill from the base of the tower. The angle formed by the guy wire and the hill is 16. Find the length of the cable required for the guy wire to the nearest pole near. Okay. Now, any suggestions?
Good question. Please, 667 is on that same line. Could we just add up 68 and 73?
16 to 67? Yes, because we're going to form a right triangle, right? So I'm going to form a right triangle like this. Where the base angle, right, this is 90 degrees, this is exactly what you said, right? So this angle is 67 degrees plus 16 degrees, which is 83, is it? Okay. Then what is this angle here? So this is what we're asked to determine, x. And we do know this length. We know this, 165. How much is this angle? Remember, we have a right triangle now. This is 90 degrees, this is 83. I can determine the angle at the top. So this angle will be 180 degrees minus 90 degrees from here and minus 83. How much?
7.
Okay. So now I only need this triangle. Well, let's see what we have. This is 165. This is the unknown. This is 7 degrees. This is 16 degrees. And now I know this. How much is that piece? I know 7, I know 16. I can determine that obtuse angle, correct? Subtracting from 180, 23. 7 and 16. So then this is 180 minus 7 degrees minus 16 degrees. So 180 minus 23. So is it 157? Correct my numbers anytime. Okay, perfect. Okay, so now in this triangle, I can write sine 157 degrees over x equals sine 7 degrees over indeed. So let's go back and discuss this before we get to come up with a number, because the answer is less important. What is important is what we have done. So we realize that if we create a right triangle we're able to, knowing 67 and knowing 16, we're able to determine this angle at the top. Knowing this angle at the top, we are able to determine this angle, the obtuse angle between the hill and the tower, the communications tower. Once we determine this angle and we know this angle, that's all we need, right? Because we know this side, we know this angle, we know this angle, we know this angle, we know this side, and we are asked to determine x. Does it make sense? Do we understand the steps? Do we have questions on the steps? Okay. So here, cross multiply, x equals 165 times sine 157 divided by sine 7 degrees.
I have a question.
Please.
So that right triangle was only used to find the angle at the top, so we don't have.
Yes.
So we don't need that anymore.
I don't need it anymore because because I don't have any information. I don't know this. I don't know this. So I don't have any information that will involve the rest of the right triangle. Perfect question. So all I needed was to determine this and determine this, and then from this triangle, which is not a right triangle, but I don't care, right? Because we have law of sines, to determine x. Very good question. Is that okay? Everyone?
I mean, would it be possible to actually solve the rest of the triangle, since you have two
Um,
like that? So you want to define.
Once
like,
so you're saying about all this triangle?
Say they didn't ask the question for x, what if they wanted the height of the entire antenna plus the.
I would have, in that case, I would, because it's a right triangle, I could possibly determine this piece because I have the angle, I have 67, I have this side, I know 90, so I can apply a law of, I can apply tangent, right?
To the other triangle as well.
Yeah, not tangent, but opposite over the hypotenuse, right? So sine. So I could determine this piece. Once I have this piece and I have this piece, I can determine that by the Pythagorean theorem. Does it make sense? Was that the question, Caleb? Okay, good. So now we are finalizing this, finding x. So we have 165, 160. I'm not sure what's happening. Please. Thank you. Okay, 165 multiplied by sine 157. Yeah, something is 165 times sine 157 and divide by sine 7. Okay, 529, roughly 529 feet. So the guy wire has to be 529 feet long. Okay, we need to talk about two other concepts here. So let's take a look. And then we can move on to law of cosines. Okay. So let's talk about the angle of elevation and angle of depression. So I stand in front of this wall and my eye level is this, let's say. If from here I look up, that's an angle of elevation. From my eye level till the ceiling, that's an angle of elevation. From my eye level to the floor, that's the angle of depression. Okay? So similar to an angle of elevation, an angle of depression is the acute angle formed by a horizontal line and an observer's line of sight to an object below the horizontal. So the angle of depression. A pilot is flying over a straight highway. So this is the straight highway, this is where the pilot is flying. That's the level, the height over a straight highway. He determines the angle of depression to 2 mileposts. So he's right here, he looks here to milepost A and determines this angle. At the same time, he looks at post mark B and determines the angle of depression on the other side, as shown in the figure. Find the distance of the plane from point A to the nearest tenth of a kilometer. So we want to determine this distance. So let's copy the picture. So this is problem 64 on 774, another application of law of sines. 7. So here's the situation. Okay, so 2 mileposts that are 6.6 kilometers apart. And we're asked to determine x. This is x. That's our question. Let's read the problem one more time just to make sure we took everything into account. A pilot is flying over a straight highway. He determines the angles of depression to 2 mileposts, 6.6 kilometers apart, to be 37 and 44 respectively. Find the distance of the plane from point A to the nearest tenth of a kilometer. Any suggestions? These are 2 parallel lines. I'm sure you remember that when we cut 2 parallel lines with a straight line, something interesting happens, right? So for example, this angle and this angle, because the lines are parallel, these 2 angles are called,
Supplementary angle?
these are, yes, they are congruent or equal, but they are alternate interior angles, right? So obviously this must equal what?
37.
37 indeed. The same thing on the other side. I still have 2 parallel lines and they're cut by this segment, line segment. Obviously this side must equal, this angle must equal 44. Good. Okay, so let's see what we know. Once I know 37 and 44, what else I know immediately?
You can see it.
Right, I can get this angle inside. Okay, so from 180, I subtract 37, I subtract 44, what do I get?
99.
Perfect. Now, knowing this side, trying to determine this side, knowing this side and knowing all the angles, I can write that sine A, which is 37, divided by, this is unknown, I don't care for it, equals sine 99 divided by 6.6 equals sine 44 degrees divided by x. This is redundant because I don't have any information about AB, about CB. Okay, so then no problem. Finding x is a piece of cake. 6.6 times sine 44 degrees divided by sine 99 degrees. And this is it. So we determined how far away the pilot is from milepost A. Okay. Yes, please.
So why can't we go to sine 37? Why can't we do this?
Because I don't have it. And I'm not interested in it.
I'm
I'm not interested. We only want to determine x. We don't
We only
want
want to jump. Sorry.
We can eventually determine the other one if we wanted to. So 6.6, if you have this number, don't torture me. Please give it to me, sine 44. And divide by sine 99. So I got 4.6 kilometers. X is 4.6 kilometers. It says to the nearest tenth. Okay. Any questions? Do we understand when and how we apply law of sines? Yes.
Instead of doing the alternate interior angles, we have just said that since it's a straight line, then all 3 angles add up to 180, so we can just subtract the
That's
37
fine.
and 44 from 180.
Of course. Of course. I just wanted to discuss that, of course. So you understand what Connor is saying? He's saying this. Since this is 180 degrees, I know 37 and I know 44. So from 180 degrees, I subtract 44 and 37 to get 99. I wanted to refresh your memory on those. And I also needed these to be in the picture so we can apply law of sines. But yes, of course. But finding 99, yes, would have been 180 degrees minus these two. But for the purpose of applying law of sines, I really needed everyone to see where the other two. But perfect. Very good question. Thank you. Okay, finally, law of cosines. When I was your age, law of cosines was not called law of cosines. That's how I'm going to write it right now for you. Law of cosines was the generalized Pythagorean theorem. So, what does it mean? It's basically the Pythagorean theorem in a triangle that is not a right triangle. That's all it means. Okay? So, let's take a look. The entertainer / lawyer. Okay, here it is. So let's take a look at a triangle that is not a right triangle. Again, the same notation that follows us everywhere. So please remember the opposite of angle A is always A. The opposite of angle B is always B. The notation is crucial. You understand that if we mess up the notation, and let's say by mistake I denote this by A and this by B, or that by C, the whole thing collapses. We're not going to get anything. Okay, so this is any triangle. If I were to say, do not write that, let's say if I say to you that this is a right triangle, it's not. But if it were, you would have said b squared plus, in this case, the way I denoted it, you will say b squared plus c squared equals a squared, correct? Right? However, what would happen next is, so a squared equals b squared plus c squared minus 2bc cosine A. If angle A is 90 degrees, what happens with this piece? Because it's 0, right? If angle A is 90 degrees, cosine 90 degrees will be 0, and this piece will go away, and we're back to the right triangle. What if I want to determine b squared? What do you think we're going to have? Because there are 3 options here, right? A squared plus c squared minus 2ac cosine b. Can anyone give us the last one?
C squared equals A squared minus 2AC cosine.
Minus 2ab times, it's not plus, times cosine c.
Wow. So this is still the law, or does it change?
This is the Pythagorean theorem, but generalized to any triangle.
So this is not.
Okay, so in case angle A here is 90 degrees, then you're back to the Pythagorean theorem. If in case angle B is 90 degrees, then you're back to the Pythagorean theorem, and so on and so forth. Ready for examples?
Is that because cosine at 90 degrees is 0?
Yes. So if A is 90 degrees, then cosine will be 0, and this goes away. If B is 90 degrees, then cosine 90 degrees will be 0, and this will go away. Perfect. Okay. So let's use the law of cosines to solve the missing angle. That's one option. Of course, we're going to end up with word problems in a minute. And also, we have a couple of situations with the area of a triangle. So that I would like to mention here, but let's practice law of cosines first. And then I'll show you 2 more formulas for the area of a triangle. The area of a triangle is base times height divided by 2, but there are 2 other options, depending on what is given to us. Okay, so let's solve the triangle, 21 to 26.
So 24.
24 we want?
Yeah.
Very good, 24 it is. So 24 on 783. A is 13, B is 11, and C is 15. We start by, Bailey, what is going on?
We're just having that.
Here's a triangle. Notation is crucial. The opposite of A is 13. The opposite of B is 11. The opposite of C is 15. You're distracting, please. Okay, so obviously we have 3 sides. Law of sines is not applicable here, right? Because if we apply law of sines, we only have the denominators, but we have nothing about the numerators. So law of sines in a side situation is not applicable. It can be applicable after we determine at least one angle. Then we can go back to law of sines. But right here we have no choice.
Now, with law of sines, I think there are only the 3 options: side, angle, angle,
Angle, side,
angle, side.
and side. Correct.
Or side is just for
This one.
Yeah.
Exactly. Okay. So let's take a look. Which angle we would like to determine? Which angle we want to determine? We want to determine C. If we want to determine C, then we will start with 15 squared equals 11 squared plus 13 squared minus 2 times 11 times 13 times cosine C. If we want to determine C, let me say it one more time slowly. So we decided to start with C. If we want to determine C first, then we have to write 15 squared equals 11 squared plus 13 squared minus 2 times these 2, that's the law of cosine, times cosine C. Okay? So we start with the opposite side of the angle we want to determine. So 15 squared equals 11 squared plus 13 squared minus 2 times this product times cosine of the angle opposite to 15. Of course, we have to solve for cosine first. Here's what I'm going to do. I'm going to move this term to the other side, and I'm going to move this term that is negative to this side, and divide by 2 times 11 times 13. So 2 times 11 times 13 cosine C will equal 11 squared plus 13 squared minus 15 squared, and now I divide by this. Do not calculate step by step. No, we calculate everything. We put in the calculator everything at once. 11 squared plus 13 squared minus 15 squared over 2 times 11 times 13. Be very careful. If you do not put parentheses around the top and parentheses around the denominator, you will not obtain the correct answer. Now, if this triangle exists, cosine should be what number? What do we expect for cosine C to be? Between? Right, but mainly between 0 and 1, right? Because it's in a triangle, right? It's not a negative angle. Perfect. Although it could be in the second quadrant, so it's possible, but it could be in the second quadrant, which is an angle that fits in a triangle. Okay, so let's put it in. Okay, so let me